Hello, everybody. I'm Aditi from ISWA, and I'm moderating today's webinar on quantifying the benefits of applying quality compost to soils. Thank you very much for joining us today. This is the last in a series of 4 webinars that we've organized over the past few months on some of the results of the study that we've been carrying out over the past 18 months. So just as a short recap for those of you who weren't able to attend the previous sessions, the first in the series, we detailed the global perspective on the production and recycling of municipal organic waste. And through our study, we've found that almost 1 billion tons of organic waste is being generated globally every year. And this figure is actually projected to almost double by 2050. The organic waste that we're referring to is made up of food and garden waste, and this can be easily recycled through composting and anaerobic digestion. Both of these technologies have successfully been established in high-income countries. And however, despite this success across much of the world, a vast majority of the organic waste is left to rot either in streets, dump sites, or landfill sites, where it's generating greenhouse gas methane. In the second webinar, we talked about the benefits of compost and anaerobic digestate when applied to soils. In the third, we summarized the state of soils in 5 countries in different parts of the world. We talked about soils in Australia, Brazil, Chile, Italy, and the UK. And in this fourth and final webinar, we are going to be continuing from the second one and quantify the benefits of applying this quality compost to soils. You will hear a lot about it in the next hour by 2 experts on biological treatment of waste who are going to present the 4th report of our study. The presentation is going to be followed by a question and answer session, and we encourage you to type your questions in the question window to your right. We will be choosing a few of these questions for the speakers to answer at the end. And we also have a bonus question for you, the participants, which you will see in the chat window in a few minutes. You may type in your answer at any time during the webinar. So before I actually hand over to the speakers, I would like to give you a big, massive thanks to the main sponsors and platinum members of ISWA who make the work that we do possible. And thanks also go out to the host of platinum members that you see on the screen. And ISWA is counting on the support of all our members. So if you're not yet a member, please take a moment to visit our membership page by visiting the link on the screen. And you can alternatively write to our memberships manager, Mr. Daniel Purchase, at dpurchase@iswa.org. We have lots of membership options available with discounts for students, for low-income countries, and also online memberships. So please visit the website and to find out more. Before going into the report, let me just take a brief moment to tell you a little bit about ISWA for those of you joining today that don't know us yet. The International Solid Waste Association is a global, independent, and non-profit making association. It is the only worldwide association that promotes sustainable, comprehensive, and professional waste management, while also encouraging a transition to a circular economy. We are open to individuals and organizations from the scientific community, public institutions, public and private companies from all around the world working in the field or interested in waste management. Our mission is to promote and develop sustainable professional waste management worldwide. Currently, we have members from over 110 countries. It's a fast-growing network, and 2 of whom we have here as speakers with us today. So without further ado, I'd actually like to give the floor now to Marco and Jane. Marco and Jane, would you please very briefly introduce yourselves? Just say your name, your role within ISWA, and your day job, and where you're located currently.
Well, good afternoon. First of all, Marco calling from Italy. I'm working as a senior expert for the Italian Biogas and Composting Association. I'm located at this moment in Verona, Italy.
Hello, everybody. Good afternoon, good morning. My name is Jane Gilbert and I'm located in the UK. I'm a microbiologist by background and I'm vice chair of the ISWA Working Group on Biological Treatment and have been working in the sector for about 25 years.
Thank you, both of you. The floor is now yours. Let's begin.
Okay, thanks, Aditya, first of all, and good afternoon to those participating. We would like briefly, today we are going to present the report we are most keen of the 4 ones we prepared. But before that, and for those of you who didn't have the chance to join us in the previous webinars, a very short summary about the content of the previous documents and reports. this investigation lasted about 18 months. It was started in 2018 and was finalized at the beginning of this year. Basically, we have 4 deliverables or project deliverables that you can access free of charge on the ISWA website. So it's sufficient that you click on this link, which you can see now, and you will be able to download the PDF version of all 4 reports. The reports should be considered from 1 to 4. The first one was realized with a significant contribution of many members of our working group at ISWA, and it's showing a global assessment about the amount of municipal organic waste which is produced worldwide and which could be recycled in terms of composting and anaerobic digestion if it would be collected separately. The report shows some key numbers and figures, like the fact that cities can play an important role in diverting organics from dump site, landfills, disposal facilities towards recycling. And more than 50% statistically of the municipal solid waste produced in the city is organic. It's made of food waste, it's made of gardening park waste, and so there are consistent amounts which can be recycled. We started exactly from this topic of organic waste because we know how dangerous it is to manage this kind of waste fraction in a non-correct waste, since dumping this kind of organic waste into landfill sites or dump sites causes a significant production of methane, of black carbon if you're going to burn it together with other waste streams, and so it affects the environment and the health of local population. We also tried already in the first report to give a rough estimation about the potentials of having people collecting separately organic waste in towns and cities and send it towards compost production. And we tried to link the potential amount of compost that can be derived from organic waste to the amount of agricultural soil at the global level. We will go back to this estimation today when we are presenting report number 4. So I'm not going to give you the detail in this moment. Why are we linking the topic of organic waste to soil? Well, there are a number of reasons for that, but let us briefly focus on 2 or 3 more evident reasons. One is that soil is a very complex structure, a mixture of minerals, organic matter, besides water and air. And we know that currently a significant amount, about 30% of the world's cropland, has become unproductive in the last 40 to 50 years. And these numbers strike with the fact that it takes thousands of years to form soil, but it takes a few decades of mismanagement to destroy it and to become it unproductive. So we see a link between the recycling of organic waste and bringing back the organics to soil in order to try to invert this systematic loss of soil that can threaten our future and especially our food security. This is the short summary of what you can find in report 1, and I'm handing over to Jane Gilbert for a short summary about the content of report 2.
Okay, hello everybody. Very briefly, report 2, and we've already had a webinar, an ISWA webinar directly related to this anyhow, so apologies for those that have heard this before. But what we did as part of the Soils project was carry out a comprehensive literature review. So we didn't actually do any scientific research, but we just did a very comprehensive desktop study, limited to peer-reviewed scientific papers and also governmental reports such as the European Commission and the Food and Agriculture Organization of the United Nations. And what we wanted to do was look at the effects of putting on quality compost and anaerobic digestate onto soil, and in particular looking at the properties on soil such as the physical, chemical and biological changes. And this was important from our perspective, both because there's been a lot of research published about the effects of compost and digestate on crops and crop growth, but less so about the underlying soil. So we wanted to try to address that balance. But also what we wanted to do was extract that information, which is often squirreled away in scientific publications and hard to read, quite technical papers, and actually pull it together into a format that can be used by non-technical specialists in soils and organic waste. So people whose job roles would involve looking at potentially trying to put in place organic waste strategy. So that was the real aim, was to try to pull all the information out into some usable reports. What we basically found was that, and it probably doesn't come as any surprise, is that composts are best classified as organic soil improvers. They've got a lot of stable carbon in them, and they contribute very much in particular to increasing soil organic matter levels. Whereas anaerobic digestates are much better classified as organic fertilizers or biofertilizers, because they're much higher in available plant nutrients. So they're much more akin to normal fertilizers which go into soils. And the little graph that we're showing on the right-hand side of that slide tries to summarize that. And that was based on a paper by Jürgensen and some of his co-workers, where they looked at the effective organic matter levels in a number of different organic materials, compost and digestate, and looked at the long-term organic carbon that was in, that would still be there in the soil after 12 months. And they grouped very neatly the composts and the anaerobic digestates and farmyard slurries into these two different categories based upon biochemical analyses of the materials. So that's the basis for a lot of the work that we're going to talk about today, as we're really talking about compost and its effect as a soil improver. Some of the benefits of applying compost and quality compost to soil, which is all summarised in report 2. Basically, it improves soil aggregation, it can increase water holding capacity, it can increase soil biodiversity, of course, soil fertility, and soil buffering and pH. And we've pulled together those pieces of evidence and information in report 2, and using that as the basis for us for the report that we will be presenting today. We also reviewed a few papers as well, and some long-term studies, in particular the Rothamsted studies that were carried out in the UK over many, many decades. And what it's thought is that by applying compost to soils that are low in organic matter, they've been degraded primarily through intense agricultural practices, that you can actually see quite a big increase in soil organic carbon levels in the soil over the first few years. And it's generally around about the first 20 years where we can see these big changes happening. And then the rate of increase then starts to slow, and naturally the soil then reaches a new soil organic carbon equilibrium level. So what we're looking at in today's report is those increases over the first, say, 20 years or so. And that's the important bit. It's that I don't have a pointer on this, I'm afraid, but it's that first part of the curve that then starts to go up before it reaches the new equilibrium. And that's really the point in that curve that we're going to be looking at today in report 4. So that's a very, very brief summary of rather a long and quite complex report. So I'm going to hand over to Marco now to briefly summarise report 3, which takes a much more global aspect.
Okay, getting back to the global aspects, and considering that these reports have been written addressing waste experts and the decision makers in municipal solid waste management, so not for soil expert, we found it to be interesting to summarize the state of soil, let's say in 5 countries, and so looking somehow also at 5 different temperature situation, agricultural practices, and so on. Again, this report hasn't been done by doing direct investigation on the state of soil, but based on existing documents, national reports, and with the consistent help of 3 co-authors, which were responsible for selected country reviews. The assessment of the 5 countries we did are those ones. So we went from Latin America, in one case Brazil, in the other case Chile, which have 2 remarkably different kind of agricultures. We then moved to Europe and selected 2 countries, one in the northern part of Europe, which is UK, and the other one in the southern part, representing somehow the situation of Mediterranean soils, which is Italy. And finally, we moved to Australia or Oceania, giving an overview on the status of soil of these 5 countries. Since we are summarizing the results, we are not going into the details of the outcome, but just to summarize, in all 5 countries, it became clear that there was no national legislation in place protecting and enhancing soil, even if all countries were perfectly conscious about the fact that soil are under threat. We found specific initiatives, or in some cases policy documents, existing legislation, and in some cases also existing measures to prevent soil damages and soil and loss of soil, but mostly on the regional level or on the district level. All countries investigated suffer from soil erosion, loss of soil organic matter, and we summarize these numbers, trying to make them comparable, even if you have to be aware that the national reports have not been prepared always using the same parameters. Here you can see a brief overview of the different threats of soil. And again, they are remarkably different, but for sure intensive agricultural practice can be found in all 5 situations, and they are contributing to this situation of soil. So for sure, all countries are losing and have lost productivity, agricultural productivity, due to soil degradation. And among the countries investigated, probably Chile is the worst one affected. And of course, the combined effect of climate change and poor land practices are continuing to erode soil at a rate that we think is unsustainable in the medium and large period. So there is a risk of threatening food security in these countries and globally, because these countries should also only work as an example of a more global situation. At the same time, it is clear that a high-quality compost brought back to soil could potentially help in reducing erosion and loss of organic matter. But of course, this is one of the methods which needs to be practiced together with better agricultural practices. And agricultural practices were not the topic of our reports nor of our investigations. Report 4, and I'm handing over to Jane, is taking benefit of the outcomes and of the evidence that we investigated in the 3 previous reports. Again, I'm handing over to my colleague, and we'll be back for the final part of the presentation.
Okay, thank you, Marco. So I'm going to briefly try to outline and summarize what we've presented in report 4. And I'm happy to say the report 4 is now finally up to download, as Aditi mentioned earlier, on the ISWA website. But what we did was we used all the data and the information we gathered during report 2 to help fill an information gap about the benefits of organic matter to soil. And what we did was look very much at the carbon sequestration potential, the nutrient potential, and also increases in available water capacity. And for the first time, what we think we've done is, well, what we think is for the first time is carried out a monetary analysis, an economic analysis of putting that carbon and nutrients onto soil. We couldn't, unfortunately, quantify benefits, for example, increases in biodiversity, biological activity, and a whole host of other benefits, because we just couldn't find the data to actually give us quantifiable numbers to actually do some of the calculations. So there's quite a big gap there in the data. So what we've shown you today really relates principally to organic carbon in soils, nutrients, and water holding capacity. What we did is we used two timescales for this. We've assumed the baseline year was 2020, i.e. now, and we've projected forward for 10 years, and the 10 years would bring us up to 2030 and would coincide with the United Nations Sustainable Development Goals. And then an additional 20 years as well, looking at countries' routes for decarbonisation. We modelled 3 different compost application rates of 10, 30 and 50 tonnes fresh mass of wet compost per hectare per annum, which is equivalent to 6, 18 and 13 tonnes on a dry matter basis. And we know in some parts of the world, a 50-tonne application rate will be quite high, but perhaps in others it isn't. So we've tried to take into account a wide range of different practices globally. We assumed 3 carbon sequestration rates based upon the work that we've done in report 2, a low one of 30 kilograms of soil organic carbon per hectare per tonne of compost per annum, 50, which we assumed to be the median, and 70, which was a high rate. And we based that upon some work that had been published by Paulson and his colleagues, which suggested that sequestration rates were generally in the region of between 50 to 70 kilograms of soil organic carbon per tonne of compost per hectare per year. And the 70 is the one that's the roundabout used by the German Humus organisation as well. But we've taken a low, medium and high once again to try to reflect different soil types, different climatic conditions, different operating conditions in different countries globally. And what we didn't want to do was overestimate potential sequestration. And we also assumed 3 different soil densities, a 1.1, 1.3 and 1.5 tonnes per metre cubed density. So a low density, a medium density and a high density, so potentially a compacted soil as well. So they were the assumptions and the baseline assumptions that we made when we did the models. We also assumed that those application rates of compost would go onto one surface area of 1 hectare of soil, which is equivalent to 10,000 square metres. And that's normally the application rates that we're looking at. We assumed that there would be annual applications of compost to that hectare of land, and that typically the compost would be about 60% dry matter, 40% moisture. So broad brush assumptions that we've made. And when it's come to doing some of the other calculations, we've assumed a soil depth of 30 centimetres or 0.3 metres, which is normally the soil depth that most experiments are carried out at generally. But it's also the depth at which agricultural ploughs will actually go into the soil and till the soil. That's the depth that we've assumed. So there are baseline assumptions. What we did was we just modelled quite simply sequestration rates, assuming these annual applications of compost. And the little graph that we've shown on the right-hand side is just for 30 tonnes of compost fresh matter per hectare per year over 10 and 20 years, apologies. And what it shows that at the after 20 years, even only putting on the low, a low application of 30 tonnes, an application of 30 tonnes of compost per hectare per year, but at the low carbon sequestration rate of only 30 kilograms per tonne of compost, we can still increase the soil organic concentrations, the soil organic carbon concentrations by a little over 10 tonnes per hectare. And at the high sequestration rate, that increases to over 25 tonnes per hectare. So yeah, it sounds good, but what does it mean? Well, when we calculate the change in the soil organic carbon levels on a percentage basis, on an absolute basis, what we can see is that we're getting some quite big changes in the density of the soil, and we're actually increasing the soil density at a low density in the low density soils of 1.1 by over 0.55%. And this means if you look at some of the classification of soils based upon the percentage of organic matter and organic carbon in them, it can actually help lift some of these soils that are actually quite critical and have very critically low levels of soil organic carbon. You can actually increase that. So we can see there that after 10 and 20 years at the different densities, assuming we're putting on 30 tons of compost per hectare at the medium sequestration rate, we can see that we're actually having some quite big uplifts in the absolute amount of soil organic carbon in the soil. And the greatest effects are those with low density, such as clay soils, where we can see the bar on the left-hand side of the 1.1, the dark green one, which increased the percentage by up to 0.55%. So that can actually really make quite a big difference, especially in countries where desertification is a big issue. But if we look at the relative increases based upon the initial soil organic carbon content, we can actually see that we can really start to appreciate how big these changes are. So depending upon the initial soil density as well, a soil with a low density of 1.1 can actually have a relative increase of 66% based upon an initial soil organic carbon level of 1%. So this shows that the biggest effects happen in those soils that are lower in soil organic carbon, so the more degraded soils. So I realise it's a little tricky to explain this verbally, but it's all in the report, and these are little diagrams that we've got in the report. So the key thing to note is that we can see some really quite significant benefits by putting on annual applications of compost onto soil. Of course, this carbon, not only is it helping improve the functionality of the soil and the health of the soil, it's actually sequestering carbon. And if we take that soil organic carbon and convert that to carbon dioxide equivalents by timesing it by 3.667, which is just a stoichiometric increase with the two oxygens attached to it, we can start to model how many tons of carbon dioxide equivalents are going to be sequestered in the soil over these periods of time. And we've shown in this table here different rates of compost application, which is the column on the left-hand side. And then moving along, we have two time frames, the 10 and 20-year time frame. And just by looking at the medium sequestration rate of 50 and applying 30 tons of compost on a fresh matter basis per hectare per year, we can sequester about 66 tons of carbon dioxide equivalents over that period of time. And obviously you can see from the table that can increase at the really high rates, application rates and sequestration rates, to around about 155 tons of carbon dioxide equivalent per hectare. So quite significant amounts. Now, what we did in this, and this is where we feel this is the first time that this analysis has actually been done, is we actually put a value on that carbon. And what we did was we used a report published in 2017 by the World Bank, where their economists, including Nick Stern from the UK and the Grantham Institute, did some work to try to estimate the price that countries, the price that globally we would need to put on carbon dioxide emissions to start to change behavior and economic instruments. And that was based upon a value of $60 per ton of carbon dioxide in 2020 this year, rising to $75 per ton of carbon dioxide equivalents by 2030. So we used that pricing, we used a straight line increase and then projected that across to the 20-year time horizon as well. And what that does is it gives us a means of estimating, based upon the carbon sequestration potential, of of the amount and the price, the benefit to society that compost is actually doing by sequestering that carbon in soils. And as you can see, at the medium sequestration rate, on a dry mass basis, it's coming in at about 9.72 euros. We've used euros, but you can convert it to any currency per tonne of compost on a dry matter basis, or around about 5.8 euros on a fresh mass basis. So we can start to use these figures now to actually start to estimate what is the intrinsic value of this compost. This is not what someone else will value it at. This is what environmentally we feel that this is its value. And what we did was we then projected this to over the 10 and 20-year periods at the different carbon sequestration rates and at the different compost application rates. And we used the figures from the Grantham, from the World Bank report, and back at a 3% per annum discount rate. So all these figures would be in today's money. And as you can see, there's quite significant potential there in terms of the value of that carbon in the soil over 10 and 20-year time periods in today's money by using the assumptions that we have made. So that gives us a potential for actually estimating values to meet the Sustainable Development Goals, and also looking further afield as well over a 20-year period. I remember it's that 20-year period where we feel that on an area of soil, we will see a much greater increase in the amount of soil organic carbon being put onto a degraded soil. So we've got some figures now to start using and to start thinking, well, what are the longer term benefits and the benefits to soil in terms of carbon? We then turned our analysis to plant nutrients, and we've just really looked at 4 types of plant nutrients: total nitrogen, phosphorus, potassium, and then also the liming value in terms of percentage calcium oxide, which is often put onto agricultural land to increase the pH and reduce acidification. And we use some nutrient levels of compost based upon some published figures for the UK, but you know, you can plug any figures into those. We've also taken and benchmarked commercial fertilizer prices over the last few years, and used UK figures as well, but I think they're broadly in line with certainly with European figures. So we've taken an average over a time period, and then used those to start to then calculate, well, what's the total value of the nutrients in compost? Now, what we tend to find is when we talk to agronomists and they use nutrient calculators, is that they will only take into account the plant available nutrients that are present in the compost. So for example, with nitrogen, somewhere around about 5–10% of the total nitrogen will be available in the first year of a crop uptake. So it's only that 5% that is taken into account. Similarly with phosphate, you know, probably around about 50%, and perhaps most of the potash. But what it fails to appreciate is the total value of the nutrients going onto the soil. So I stress we haven't done these equivalent values for in terms of calculating nutrients that are available to plants for crop growth. This is about the nutrients, the value of those nutrients being put onto soils, and cumulatively as well. And as you can see from the bottom calculations on the right hand side of that table, we took 2 types of compost. One was a green waste or a yard waste only compost, which is generally tends to be lower in nutrients, and one that incorporated yard waste, green waste, and food waste. So probably what we would normally call in Europe bio-waste compost, but both from separately collected organic waste streams. I do have to stress that. And when we look just at the total figures, you can see that actually green waste compost on a dry matter basis is about 23 euros in total nutrient value per tonne of the material. For bio-waste compost, around about 30. And if we consider it on a fresh mass basis of compost that will be delivered onto a farm, they're around about 17 and 20 euros per tonne once the moisture has been taken into account. So these are still much, much higher than most compost is generally sold for. And of course, we did exactly the same as we did with the carbon calculations. Worked out total application. So this isn't plant available. This is the total quantity of nutrients being put onto soil every year over 10 and 20 year time frames. And if we just look at the figures on the right hand side, where we model 50 tonnes per hectare, using the figures that we've just shown you in the previous slide, and discounted those numbers back using a 3% discount rate. So we've got the cumulative value in today's money. We can see that over a 20-year period, it's just under 14,000 euros worth of total nutrients that go onto 1 hectare of land. So really quite significant. And even at the lower application rates, they're still, still not insignificant. So finally, we then did some calculations after we did the nutrients on available water capacity. And what we did was use figures that had been published, I think, in a 2018 paper, which was a meta-analysis of about 90 other papers. And they suggested that a 1% increase in soil organic carbon levels would increase the available water capacity by 2.1% on a mass per mass basis. So we use that figure. We do say it's an awful lot lower than some other authors use, and it is quite variable. The calculations for the available water capacity are inherently much lower, and the benefits using those figures are much lower, I'm afraid. So even at the 50 tonne per hectare per annum, after 20 years of putting that carbon on at the medium sequestration rate, that 50 kilograms of organic carbon per tonne of compost per year, it was only equivalent to about a 6.3 litre per metre square increase in available water capacity. Or to put it another way, when you take into account the volume at the 30 centimetre depth, it's only equivalent to about 21 litres of extra moisture that the soil will hold per metre cube, or 2.1% on a volume mass basis. So much, much lower than perhaps intuitively people would think, but we didn't want to try to overestimate the benefits, and we use that peer review data. So I think it's one area where we could potentially see a lot more research done. So that's the nuts and the bolts of the analysis that we carried out. It's all detailed in the report, including all the assumptions and the commentary that go with it. So I hope that's given you a bit of a whirlwind overview of what report 4 actually has in it. I'm going to hand back over to Marco now to summarize what the implications of this are going to be.
Yes, thank you very much, Jane. I think the participants today have probably understood that there is a lot of modeling which regards report number 4, and let's use again the outcomes of this modeling to have an insight about some global implication. Now, if we look at the organic waste arisings per country, which we investigated in report 1, or the status of soil of some of the countries which we investigated in report 3, well, from the modeling done and which Jane Gilbert has presented to you, we can estimate, based on the amount of organic waste arising in each country, we can estimate how much compost you can produce in each country. And if we use it on soil, what is the potential increase in soil organic carbon per annum? And of course, the CO2 sequestration, which can be achieved. And again, using 2 parameters to have an idea of equivalency, which is the number of passenger vehicles which could be driven for 1 year, in thousands, or the number of households which can be applied with electricity, so having a comparison in terms of CO2 equivalent emissions. I said it's a tentative calculation, but based on quite robust outcomes, again, based on data from peer-reviewed documents. If we move from single countries to our global perspective, knowing that we have a potential of roughly 935 million tons per annum of organic waste, which is produced by human settlements, well, then we know that if it is transformed into quality compost, and again, I stress it, it means compost obtained from feedstock which has been collected separately from household or commercial activities, or producers anyway, not from mechanical sorting. Well, anyway, in that case, we know that we have a potential of sequester in soil almost 34 million tons per annum of CO2 equivalent. And this would be almost equivalent to up to 1.7% of the global amounts of CO2 equivalents that soils are technically able to sequester. And again, we use this parameter of conversion, showing how much these potential emissions are, and they are equivalent to roughly 44% of the total number of passenger vehicles in the EU24, which are roughly 70 million vehicles in total. Another way of looking at the carbon sequestration potential at the global level is switching back to an initiative which was launched some years ago, aiming to increase the soil organic carbon in stocks, soil organic carbon stock in soil by 4 per mille annually. It is called the 4 per mille initiative. So based on our modeling, we quantified the tons per hectare of compost in terms of fresh mass, which are needed to increase the soil organic carbon in a soil which is starting from a very depleted situation of 1% sock content mass to mass, adding 5 tons fresh mass per hectare and year of compost. And so we know that globally we could provide 4% of the global croplands with quality compost. Again, it's a way of trying to put general strategies and targets at the global level into numbers which are understandable for waste managers and decision makers. And again, compost is a limited resource, it's a precious resource, because as you can see, it can satisfy only a fraction of the global cropland. Another way to express our outcomes is to have a look at market values. And I would like to thank all of you who send in some rough estimation about the current market value of compost in your country. We did the same, considering that in many countries where the composting sector is quite developed, some refer, for example, to the United States or to many countries in Europe, well, compost is sold at high volume in bulk and at low value, so a few dollars or euros per ton. And normally the range is between 0, which is the worst situation, and at least in Europe or in the documents we revised, up to 15 euro per ton in terms of fresh matter. We know that the true value of compost, if we account the nutrient contents and the carbon sequestration value, should be much higher. And as Jane has shown you before, we know that there's a cumulative value of up to 6,400 euro per hectare over a 10 years period. And we considered also these values. So if you consider the carbon value through carbon sequestration and the total nutrient value, the range, the value of compost in terms of euro per ton fresh mass changes between 21 and 28 euro per ton. And unfortunately, this value is generally not reflected in the price that compost is giving in selected countries. And so this was also the why we asked you to give us an insight about the cost of compost in your country. And it's remarkable that the highest value are exceeding 200 or 300 euro per ton. And currently the highest value is around 800, if I calculated correctly, in Nepal. But be aware that where large compost production exists in a single region or country, the prices are dropping down significantly and significantly below the value the compost should have. Again, if we apply the value of compost based on its carbon sequestration potential and its nutrient content on the global amount of compost that we could produce, which are around 300 million tons per year or per annum, well, then we know that the total value of compost could be in the range between 6.6 and 8.8, let's say 9 billion euros per year in today's money, of course. So again, recycling organics into compost has a value, and it can be significant at the global level. For us, it is very important that decision makers become aware about this fact and do or repeat this analysis at their local, regional, national level to see if these economic advantages could be included into strategies for managing soils or into their priorities in managing municipal solid waste and enhancing recycling of collected organic biowaste. Good. We are almost there at the conclusions. I would like to thank you for having participated in this event and all the other 4 ones. And again, to switch between the speakers, I'm handing over back to my colleague Jane Gilbert for the final conclusional remarks, and then we are open for some questions and, of course, answers. Thank you very much.
Okay, thanks, Marco. I've just been desperately trying to answer a few of the questions, so I hope I've managed to, they're vaguely sensible. But really, just to conclude, what we believe this study is the first economic assessment of compost value, primarily taking into account theoretical carbon sequestration rates in soil. So we have a first step to starting to value the carbon in soil and not just the nutrients. What we very much hope is that the report will provide a mechanism for agronomists and decision makers to start to value the carbon and nutrient, inherent carbon and nutrient content of compost, and to specify it as a project to start to mitigate some of the detrimental effects of soil erosion and climate change, especially in parts of the world where desertification is becoming such a problem. And if you read report 3, the impacts in Chile really are quite stark and really quite scary. So you know, hopefully we've tried to link up organic waste recycling with the people who will be using soils, namely the agronomists and the farmers. The potential production of quality compost could increase the levels of soil organic carbon, the soil organic carbon stocks, by 0.4% in about 4% of the world's croplands. And that links in very neatly with the 4 per thousand initiative, which I would, if you're not aware of it, please Google it and go and have a look at their website. That was an initiative set up in line with the Paris Accord by the French Environment Ministry, and they're looking to try to increase soil organic carbon levels globally as a greenhouse gas mitigation measure. So it's definitely worth looking at them. And it's been interesting to see the different prices of compost, but I guess what we're talking about here are bulk materials going onto soil, so not necessarily quality compost that are being developed and bagged for use in growing media and sold directly to hobby gardeners or through shops. What we're talking about here is the bulk material going on. But just if we take into account the carbon and the total nutrient values in those composts, we calculated that they're coming in between 21 and 28 euros per ton of compost on a fresh mass basis, and not the dry mass basis, based simply on the amount of carbon that would sequester in the soils and the total nutrients that are being put onto the soils. And as the benefits of putting compost onto soils is cumulative, especially on degraded soils with low initial organic matter contents, certainly compost has a role to play in meeting the United Nations Sustainable Development Goal target by number 15.3 by 2030. And I think that's an important message for us all as professionals working in our different fields to start to think about and communicate. So hopefully we've given you a bit of a whirlwind of report 4 and some of the key findings from it. And it would be good to have some, to carry on that, those dialogues with yourselves as part of our ISWA Biological Treatment Working Group, which is for members to join. So I'm now going to just hand over back to Aditi to sum up and to set us some questions to answer.
Thank you both for such an excellent presentation, and also to the participants who've actually answered our question on the price of compost. Thank you also for very relevant and interesting questions in the chat box. Marco and Jane have tried to answer a few of those, and depending on the time, we'll actually get back to those very soon. But I'd actually like to start by asking a few questions, and Jane, over to you at this point, because in the 4th report, we are quantifying the benefits of applying quality compost to soils. Did you see common benefits across regions, despite the geographical and other differences? And you've listed global implications of the carbon sequestration potential. Could this be uniformly realized across regions? What are your thoughts on that?
Well, I think the key thing to remember, Aditi, is that there's no one-size-fits-all solution to any of this. There is no magic bullet that will sort out all the problems globally. There's different ways of doing things, excuse me, but different areas will have different types of organic waste produced in different ways, different potential to collect and treat those. But I think the crucial thing and the crucial point that has come out of all 4 reports that we've published through ISWA is that there's a need for our sector to link up and to create strategic linkages with other sectors, and in particular looking at the agricultural sector, because they are the land managers, they are the guardians of the soil organic carbon. So we don't really need to start thinking much more laterally and developing trust and good business models between the organic waste sector, the treatment sector, the manufacturers of good quality compost, and those that are going to use it. And long-term strategic linkages are going to need to be developed. And of course, they will be different in different parts of the world, depending as well upon the type of agriculture, whether it's large centralized agriculture, for example, in North America, parts of Northern Europe, or whether it's much more decentralized, for example, parts of Africa and South America. So very much think about these strategic linkages and start to build trust and start to communicate with them. And I think that's probably the way to think about it. It's thinking about partnership, and it's thinking about strategic links with all of these sectors, because that's going to be so important from a circular economy point of view. We can't just operate in isolation.
Absolutely, partnerships are key. So moving on to just following up on this question, Marco, what recommendations can you suggest to low and middle income countries to effectively manage their organic waste arisings and also benefit from the carbon sequestration potential of applying the quality compost to soils?
Well, again, it's not easy to give an answer working for everywhere or everybody. There are 2 aspects which I think are important. First of all, it's an economical one. Producing compost, bringing it back to soil is something which is done by, let's say, the local economy. And normally compost is used at a distance of maximum 50 kilometers from the facility, which means that especially in low-income countries, whose imports depend on the price of international commodities, and chemical fertilizers do depend on the price of international commodities, well, compost is probably going to be produced at your local costs. And so it will be stable and available as long as it is clean. So it's relatively easy to realize a closed loop system. The other aspect is a basic aspect about municipal solid waste management. We know that in low and middle income countries, disposal sites are basic. in terms of preventing damages to the environment. So a strategy being able to divert organics, at least from this dump site or poorly managed disposal sites, are a win-win situation. You prevent environmental emissions on your disposal system. You recycle organics quite simply into compost. Final comment is, make it simple, start from pilot scale, small initiatives, local initiative. Do not overspend in CapEx in terms of machinery and equipment. Keep it simple, and don't forget that one of the beautiful things of composting or biological treatment of waste is that it can be scaled up according to your needs. So the more your organics you're able to collect, the more you can rise your composting capacity in time.
Thank you very much.
Rome wasn't built in a day, and this applies also for composting facilities.
Absolutely. Thank you, Marco. Pivoting to Jane, I mean, we're actually running out of time quite quickly, but I have a few more questions for you. When we did this research, did you come across specific challenges or data scarcity issues? And was the information readily available? And if it wasn't, which it wasn't, well, how would you suggest that we remedy this?
Well, I think there's two areas there, Aditi, and I'll try and keep this quite concise. First of all, as I said, the information about increasing available water capacity does seem to be quite limited. So that's one area of research where we could usefully channel some research energies into. But I think also as well, where we really have we just tend to deal with composting as a black box. It's looking at the biodegradation of these larger macromolecules, of the biochemistry of degradation, and following that through into the formation of stable humic substances, and then understanding better how those stable humic substances behave and continue to be formed when compost is added to soil. They're going to be complex experiments. Some will be lab-based, some will need to be necessarily outdoors in the open air, actually in a field doing those works. There's that research, and also looking over longer time frames as well, 10, 20, 30 years. So we're looking at complicated experiments and ones that will be over a long time frame. But fundamentally, I do feel that that's a big area where our understanding and our modelling of organic carbon flows through the systems and behaviour on soil could definitely be improved. So anybody knows, any good researchers and also any research funding, please let us know.
Thank you. That was a nice call for funding for the next initiatives. We have exactly 3 minutes, so I'm going to keep it short. I don't think we'll be able to get to too many questions from the audience today, but we have collected them, and hopefully we can maybe for all the webinars make a document that we can release. But going over to you, Marco, we have consistently over all the webinars stressed the importance of separately collecting organic waste. You've said it today as well, and meaning that the compost or digestate is of high quality and is not contaminated. Marco, can you again briefly explain or give an example of a country that's doing this effectively already? And there was also a question from the audience member, and he said, Stan said, what defines a quality compost? So you've answered him already, but reiterate.
I try to explain it by two examples. One is from the country I'm coming from. Italy has no obligation to separately collect organic waste, but since 20 years, compost produced from separately collected organic waste is a product. Compost from MBT is a waste. This concept can be found, since many of the participants are not able to read Italian, if you look at the very recent European fertilizer regulation, which acknowledge that compost and digestate obtained from separate collected feedstock are end of waste, which means they are a product. So in practical terms, it recognizes more than 30 years of evidences of these recycling sectors that you can prevent physical contaminants like plastics, but not only, but plastics are an issue today, at least worldwide, and chemical contamination, heavy metals in compost, if you're able to sort your organic waste, let's say at home, to make it very simple. So local legislation have recognized it in many parts of the world. I took the Italian example, but the EU example is very recent and can be read in, I think, at least 12 languages. So if you want to Google it It's a fact-based, evidence-written document which says that this is the direction to go if you want to produce a safe organic amendment or fertilizer for your soils.
Thank you for keeping it short. We have reached the time of our webinar, but I did want to ask about markets and so on. So maybe this will be the last question. Jane, over to you. Because several times I hear from people all around the world, actually, that it's so hard to establish markets for compost and other products. So is it, and you've already explained this it's in the report, you've also said it in the presentation, is it a matter of not pricing the products correctly, or what do you think it is?
Quality compost is a product, and the same as any product, it needs to be marketed. The marketing needs to be based on good science and good information, but also because we're talking about products that will be used year on year, it's about creating good strategic linkages with end users, with the farmers, and setting up a good strategic partnership. Communication and partnership, I think, in both of these areas are the key to realizing the value of compost and marketing it effectively. And we just hope these reports in some way will help practitioners do that.
Right. We do really hope so. The last thing before we go, and I really want to also talk about the events that are coming up next for us. Both of you, just in two short sentences. So where do we go next? Because given the excellent results from the Soils project that we've done over the last 18 months, we've gained a lot of traction. There's a lot of interest. What do we want to focus on in the future? Any upcoming initiatives or projects that we're looking at? First, Marco, then Jane.
If I would have the possibility, well, I would like to, apart from project, I would like to have a significant raise in awareness about the issues of soil and soil health in two kinds of groups or targets, as communicating experts says. One is population. Global population is unaware. If you ask them about the risk of plastics in the sea, they know. And the other one is awareness and commitment to decision makers. Right. Which is one of the aspects that Jane and me, or all the people which worked at these 4 reports, considered when we prepared them. We need decision maker to be aware and committed. On that, I kindly ask also, if I may, the participants to look at the SOS Soil Initiative, which Aditi, you are going briefly to comment at the end, because it's a way, at least, of making pressure, making our decision makers at the EU level at least aware about the fact that we need consistent commitment to preserve our soil in the medium and in the future.
Thank you, Marco. Jane, your last comment.
That's great. I think really what I would like to do, decision makers, policy makers, whilst they consider the environment, they always talk money first. And what I would really like to do is start to refine some of the economic models, take them a step further, and start to integrate those into other models for farming, for example, and also for soil health as well. So that's something that we can do relatively easily without having to get our hands and our feet all dirty with composting fields. So from my perspective, I think that would help, and that would dovetail very neatly with what Marco has just said as well.
Thank you very much. We're coming to the end of the whole series. Actually, stay tuned. We have a lot more initiatives that are ongoing. We have a series of webinars on different topics that come up. You can go to the Soils page to find out more about our reports. You can subscribe to the SOS Save Soils, Save Organics in Soil initiative. Sign up for it. You'll receive the newsletter and find out more about their events. And we have a big event, ISWA event coming up in September, where we will also be presenting our summary and also have the European Compost Network with us at the Global Resource and Expo and Forum on the 22nd and 23rd of September. You can just sign up, get your tickets, and be part of the event. Finally, I'd like to just say thank you to the all the participants that stayed with us all through the 4 webinars. And I would like you to, if you want to go back and see any of the presentations, it's all on the ISWA YouTube channel. And so join us for the other sessions and see you at the event in September. Take care and thank you very much.
Take care. Stay tuned.
Yeah. Okay.
Bye.
Thanks. Bye.